How to solve this problem? Let us see. This is asked in 815 2015. So switch K is closed at t equal to 0. Series RL circuit. Find d square I by dt square 0 plus. So to answer this, you can start write the mesh equation. So V is equal to R into I of t plus LDI by dt. So simplify this set t equal to 0 plus. What is given here? IL0 minus 0. IL0 minus 0 given. What is IL0 plus? So therefore this is V equal to R into I0 plus L I prime 0 plus. So what is I0 plus anyway? 0. Therefore I prime 0 plus answer is V by L. But what we need is I double prime. Don't differentiate this. If you differentiate this, you'll get 0. Don't do that. That's a common blunder. Now differentiate this basic equation. Derivative of constant 0. Then R into R into I prime 0 plus I prime 0 plus L I double prime 0. So from this I double prime 0 plus equal to what is I prime 0 plus is V by L. So this is minus R into V by L by L. So minus VR by L square. Minus VR by L square. Okay. So always di by dt, d square by I, d square I by dt square and so on. We solve with the help of basic time domain equation. So that is important. So this is another problem, little bit lengthy. So don't get afraid of it. So here capacitors are there, 2 capacitors, 1 inductor. Here switch K open at t equal to 0. Switch K open at t equal to 0. And find dIL by dt 0 plus. IL is given here. dVc1. C1 is the capacitor here. dVc1 by dt 0 plus. So how to find this? Anything at 0 plus, first we should go back to 0 minus. So 0 minus, what is the equivalent circuit first? So draw the equivalent at t equal to 0 minus. Equal to 0 minus is obviously steady state. Steady state capacitor is open, inductor is short. So accordingly you can switch is opened at equal to 0, but 0 minus switch is closed. Here VC1 0 minus. Here VC2 0 minus. Voltage always plus minus important. This current is IL0 minus. So this equivalent circuit is valid at 0 minus. What are these values? 3 ohms, 2 ohms. 3, 5, 2. 3, 5, 2. So looking at this circuit, we have to find VC1 0 minus, then IL0 minus, VC2 0 minus. So this path is closed like this. So inductor, so this is the closed. When this is the closed path, what is the volt? VC, this is short circuited. So VC1 0 minus, VC2 0 minus is equal. But what is VC2 0 minus? This 10 volts dividing between 3 and 2. Because this is short and 3 and 2 series, applied voltage 10 dividing between 3 ohms and 2. But this voltage is across 2. So applied is 10 into 2 by 2 plus 3, 5. So 5, then you will get 4 volts. VC2 0 minus VC1 0 minus here. This is also 4 volts. Then what is IL0 minus? So loop is this. This is the closed path. So therefore 10 divided by 3 plus 2. 3 plus 2 is 5. So you will get to 12. So IL0 minus 2 amps, correct? VC1 0 minus equal to VC2 0 minus equal to 4. Next 0 plus. Now draw the equivalent circuit again at t equal to 0 plus. So at t equal to 0 plus, what is the rule? Capacitor replaced with a voltage source of 4 volts. Inductor replaced with a current source of 2 amps. This is 4 volts. Two ohms, 5 ohms, ohms, 10 ohms. So what is VC20 plus anyway same na? VC20 plus equal to VC20 minus, that is 4 volts. So here this is C1, this is C. VC10 plus is equal to 4 volts. IL0 plus is same as IL0 minus 2 amps. So let us assume 0 plus switch is open na? When switch is open, this will not be there. Is open na 0 plus. So, so let us call this current as I 5 volts. This current is IL. This current is IL minus I5. This current is I3. So what is this current? What is entering? This is entering, this is entering, but this is leaving. So I3 plus I5 entering minus IL leaving. Minus IL leaving. Now we have to write mesh equation. So if I write a mesh equation here, actually there is an inductor here. So there is a capacitor here. There is a capacitor here. So what is this mesh equation? L DIL by dt LDIL by dt plus 5 distance into I5 O equal to 0. What is I5 ohm? What is the voltage here? 4. What is the voltage here? 4. Voltage here 4, voltage here 4, current is 0. Therefore, I5 ohm is 0. Therefore, IL prime 0 plus answer is 0. IL prime 0 plus answer is 0. So this is over. Next. Write the mesh equation in this loop. What is that? 10 is equal to 3 into I3 plus already initial voltage 4 plus 1 by C1. What is C1 value? 1 by 2. So this is 1 by 2 integral 0 plus 2t. And what is the current there? I3 plus I5 minus IL dt. So this you have to simplify. Now differentiate, you get 0. 3 I3 prime plus 0 plus 2 I3 plus I5 minus I. So 0 equal to 3 I3 prime 0 plus 2 I3 0 plus I5 0 plus IL 0 plus. So 0 equal to 3 I3 prime 0 plus I3 0 plus already done. Na? What is I3 0 plus? Not done. What is I3 0 plus? This voltage is 4. Voltage here 4. Voltage here 10. So what is I3 0 plus? 10 minus 4 by 3. So 6 by 3 is 2 amps. So I3 0 plus is 2. Then I5 0 plus already done 0. 0. IL 0 plus. IL 0 plus is 2. Now this solve for I3 prime 0 plus. You will get 0. Next, we want this expression Vc1 of t. What is Vc1 of the expression? Minus 3 I3 plus 10. This is voltage here, na? So started positive, go to negative. Minus 3 into this current plus 10. Minus 3 into I3 means I current in 3 ohm resistor. Now differentiate this. dVc by dt 0 plus is equal to minus 3 I3 prime 0 plus and derivative of 10 anyway 0. So minus 3 into 0 equal to So what is VC prime 0 plus answer? VC prime 0 plus answer is so VC prime 0 plus is 0, IL prime 0 plus. This is the question. Okay. So like this you have to solve. Carefully go through this. This is another problem. Steady state reached with the switch open and closed at equal to 0. Closed at equal to 0, not 0 plus. Closed at equal to 0. Find IC 0 plus VL 0 plus. So this is easy problem because they are asking 0 plus. First work out at 0 minus. So at t equal to 0. 0 minus steady state inductor is short. Capacitor O. And 0 minus which is open. It's current to 2 amps. So looking at this, what is this current we call it as? IL0 minus. What is the voltage we call it as? VC0 minus. So this is open, this is open. This 2 ampere will flow here only. Therefore, IL0 minus equal to 2 amps. VC0 minus. So started positive, go to negative. 2 into 2, 4 ohms. So IL0 minus 2 amps, VC0 minus 4. Next, what is asking IC0 plus VL0 plus. Now again draw the equivalent circuit at T equal to 0 plus. This is 2 amps. Replace this with a current source. Current source of how much? 2 amps. Capacitor replaced with voltage source of 4 ohms. And here switch closed. So what is asking question? IC0 plus. This is a capacitor, na? IC0 plus asking. VL0 plus IL0 plus easy. IL0 plus anyway 2 amps. VC0 plus also easy anyway 4 ohms. But here is asking voltage, here is asking current. So to answer. If this is 4, what is voltage across 1 ohm also 4 volts? Na? Voltage here is 4, so 4 by 1. 4 by 1. This current is this current is 4/1, 4 amps. Here, what is the current entering? 2 amps. How much going here? 2 amps. So, what is the current here must be 0. So, 4 ampere going like this. If here 0 means what is the current here also must be 0. So, this 4 is going here only. So, looking at this circuit, what is IC 0 plus minus 4 amps? Minus 4 amps. Next to VL0. You can't find this voltage directly across current source and started positive, go to negative. Like so here 2, but 2 coming down now. So minus 2 into 2, minus 2 into 2, here plus 4. So this answer is J. So VL0 plus 0, IC0 plus minus 4. Like this we can answer. The DC analysis concepts, so if you are confident, these resistive networks we can analyze. Another problem. Find IC0 plus. So because 0 plus again draw the equivalent at t equal to 0 minus first. 0 minus which is open. Capacitor open. So always capacitor voltage which is 0 minus, like no inductor in this. So looking at this circuit, we have to answer VC 0 minus. This loop is anyway open. So 5 volts dividing between 1 ohm and 0.5 plus 1, 1.5. So that is 5 into using voltage division. 1.5 by 1 plus 1.5. So 2.5. So we get 3 volts. So VC1 0 minus is 3 volts. Next, what is the question is asking? IC 0 plus. So again, let t equal to 0 plus. 0 plus, which is anyway closed. capacitor replaced with voltage source. This is 3 volts. Applied to 5. This is 2 ohm given already. So in this, what we want is current. This current is IC0 plus. So how to solve this IC0 plus? To analyze this problem, say two source problem. You can use mesh analysis, you can use nodal, any technique. But what is the voltage here is 3 volts. So we have to introduce one more unknown V. Introduce one more unknown V. Right, D. What is the voltage here is 5. Solve for V, writing nodal. So assume this current leaving, this current leaving, this current leaving. So V minus 5 by 2 plus V minus 3 by 0.5, V by 1 equal to 0. Solve for V. So that the answer is 17 by 7. After this, write nodal equation here again. So assume this is entering, this is entering, this is leaving. So sum of the currents entering equal to leaving. So straight away, what is leaving? IC0. What are the currents entering? 5 minus 3 by 1 plus V minus 3 by 0.5. So this V is known now. Substitute. Simplify, you get 0.85 amps. 0.85. So IC0 plus is 0.8. Without knowing this voltage, you can't get this current. That's why I've written one nodal equation, solved for V, then IC0. No other way. So here, find V, this V. V is across the switch. V at 0 plus. So first understand the problem. Switch open at t equal to 0. Capacitor is there, inductor is there. Is asking V at 0 plus. So first to draw the equivalent circuit at t equal to 0 minus. Without knowing 0 minus, you can't get 0. So 0 minus is a steady state. Steady state capacitor open. Inductor short. So here VC 0 minus. Here IL 0 minus 5 ohm. So this is the voltage here. V. V here across the switch. But what is the switch status at 0 minus? Is closed. So switch is closed. 0 minus switch is closed. When switch is closed, V of 10 volts. So this switch is closed. That means what is VC1 0 minus? VC0 minus 0. What is IL0 minus? This 10 is going like this. So 10 by 10 is 1 amp. So VC0 minus 0, IL0 minus 1 ampere. We want V0 plus. Again, draw equivalent circuit at T equal to 0 plus. Zero plus, replace capacitor with the voltage of 0. And what is the switch status? Open. Inductor with the current source. Current source of 1 ampere. This voltage is V0 plus. It's 10. So here switch is open. This is 1 ampere. 5 ohm resistor. 10. So how to find V0 plus? Started positive, go to negative. You can't go like this because of current source. Better go this way. Started positive, go to negative. So looking at this circuit, V0 plus equal to 5 into, what is the current in this loop? Here already 1 ampere is there, na? Entire loop 1 ampere only will flow. So 5 into 1 plus that voltage anyway 0. So what is the answer? 5 volts. 5 volts. This is a simple problem. This tau is not time constant, it is the system. Some books they indicate system with tau. System means some network, can be electrical, some system. So to this system, when step is applied, this is the response. If this is applied, what is the response is asked. What is the input now? 3u of t plus delta of t. This is asked in Vizag Steels long back. So output indirectly, what is asking? One step response, but the step is multiplied with 3. Unit step applied, this is the response. If 3 times of unit step is applied, what is the output? 3 times of 1 minus e power minus 3. Network is by default linear network. If input is increased 3 times, output also increase 3 times. Plus impulse is applied. Impulse response. How do you get impulse response? Impulse response is nothing but derivative of unit step response. That is 1 minus e power minus 3. So this is 3 minus 3 e power minus 3t. Derivative of constant 0. minus e power minus 3t into minus 3. So minus minus become plus, this cancel. So you get only 3. So 3 is the answer. This is simple. So this circuit, a DC voltage of impulse is applied. Find I of t. It's very easy. So using Nodal equation, I of t, this I of t is nothing but IC plus IR. But what is IC? C d by dt of what is voltage applied here? Delta of plus current flowing through resistor is also voltage by resistor. So derivative of impulse is a doublet. Delta prime t we indicate delta of t by r. What is this named as? Doublet. That's all. So C delta prime of t next is the answer. So similar problem solved earlier. I0 plus, I prime 0 plus, I double prime 0 plus. Write a mesh equation and differentiate again and again. Solve this. Answers given, you can work out yourself. This is little bit lengthy. So find I20 plus di2 by dt 0 plus. Here loop currents are given. This loop current I1, this loop current I2. So as usual, draw the equivalent at equal to 0 minus. 0 minus switch is open. Switch is open. Sorry. 0 minus switch is closed. Here switch is open at t equal to 0. So 0 minus already closed. And there is a resistor here. And 0 minus steady state inductor is short. Capacitor open. This current is IL0 minus. This voltage is VC0 minus. Applied E. So looking at this problem, this circuit, what is IL0 minus answer? This side loop is open, na? So it is nothing but simply E by R. IL0 minus is E by R. Then what is VC0 minus? So started positive, here drop 0, here also drop 0. So okay. Now at t equal to 0 plus. At t equal to 0 plus, switch is open. Inductor with current source of E by R. Capacitor with voltage source of 0. And what is given? This is I1 0 plus. This is I2 0 plus. So look, when this is open, what is this loop current? 0, na? 0. So I1 0 plus is 0. This current is 0 because here it is open. Then I2 0 plus going up. What is coming down? E by R. Therefore, I2 0 plus must be minus E by R. Minus E by R. Now, what is the question? I2 0 plus over minus E by R. I2 0 plus minus E by R. Next to I2 prime 0 plus we have to find. So whenever this derivative, then we have to form one time domain equation. So in this loop equation, you have to write. So what is that loop equation is? L di2 by dt. I2 going upward, I am also writing same dash. So L di2 by dt plus R into I2 plus 1 by C integral 0 plus 2t. The current in that is I2 equal to 0. Now we want I2 0 plus. So therefore L I2 prime 0 plus, then R into I2 0 plus. This is t equal to 0 plus, this is 0. So therefore I2 prime 0 plus is equal to minus R I2 0 plus. I2 0 plus is how much? Minus E by R whole divided by L. So you get to E by L. E by L. The purpose of solving all these problems is to get the confidence how I am analyzing. So I2 0 plus E by. So this is also a little bit logically you have to answer. So your switch K moved from A to B at t equal to 0. Moved from A to B at t equal to 0. The current I, here this current I, small r capital, don't worry, current I through the inductor satisfies following conditions. I0 minus given minus 8, di by dt 0 plus given 3, I infinite given minus 4, Find the value of R. Find the value of R. So as usual, solution will be like draw equivalent circuit at t equal to 0 minus. Zero minus, which is connected to A. And inductor is short. So this value given E, here 3. This current is I0 minus. So what is I0 minus? Looking at this circuit, I0 minus E by 3. Actually current will flow like this, but we want reverse, minus E by 3. But in the given problem, I0 minus is minus A. So solve for E, you get 20. So E is 24. That is one answer. The help of this given data, we find out. Next, after it is connected to B, here di by dt 0 plus given. So after it is connected to B, you write a mesh equation, loop equation. What is that loop equation? That loop equation is E2 equal to, when I am writing E2 equal to, start at positive, go to negative. So that is nothing but minus 2 di by dt and minus R, because current is going like this. We are going opposite, minus R into I. So from this minus 2, but now E2 0 plus. What is E2 at t equal to 0 plus is E2 only given, equal to minus 2. What is di by dt 0 plus given? 3 minus R. What is I0 minus I2? I0 plus also same. Sudden change of current in inductor not allowed. So this is also minus A. So from this E2 equal to minus 6 plus 8R. This is one equation. This is one equation. What is other data given? I infinite to minus 4. After switch connected to B, steady state again inductor is short. Again inductor is short. Therefore, at t equal to infinite, steady state, inductor is short, but switch connected to B. This is E2, and this is I infinite. This is R. So what is given I infinite? What is I infinite in this? Minus E2 by R. But already I infinite given minus. So from this E2 equal to 4R. Equation number 2. Okay. So two unknowns, two equations. Two unknowns, two equations. Solve for only R. We'll get 1.5. So that is a question. Find the value of R. Some other data given, this unknown you have to find. E1 we find out. E2 not necessary. Or E2 also you can find, not issue. But question is asking only R. We solved only R. This is another special model. Already solved it. Saving time. Look at this. The switch is caused to snap back and forth between two positions A and B at regular intervals equal to L by R seconds. So this switch is connected to A, how much duration? L by R seconds. Move to B, how much duration it is connected to B? Again L by R seconds. So every L by R seconds it is oscillating or switching between A and B. After a large number of cycles, the current flowing through becomes a periodic, as shown in the plot. Determine the I1. So when it is connected to A, current increasing exponentially, connected to B, decreasing exponentially, but it will not come to zero. It is a duration of 1 L by R seconds only, 1 tau only, it is connected to B. So reduce it to some value, again connected to A, increase, again decrease, again increase. So at one stage it will reach to steady state and oscillating between I2 and I1. You go to I2, again come to I1, again go to I2, again come to I1, like that. So he's asking what is the value of I1. So logic is carefully understand this. This is increasing exponentially. It is going, when switch is connected to A, this current is going towards final value of E by R. And this switch connected to A, it is going towards final value of E by R. What is final? E by R. It starts with I1. When it is connected to B, it is a value of I1. So initial value I1 minus final E by R, e power minus t by tau is equal to I of t. Now at t is equal to tau, same equation I am replacing t with tau. At t equal to tau, it is reaching value of I2. I of t is a general expression. At duration of tau, it will reach to value of I2. That is equation number 1. Equation number 2, from I2 it is decreasing exponentially towards I1. So now I2 e power minus t by tau, which is decreasing exponentially. Again, you can substitute initial and final. You will get, it starts with I2. Initial value I2, final value 0. So expression will be I2 e power minus t by tau. At t equal to tau, it will be I1. If you look at this, so I2 to go towards I1. Starts with I2. I2 e power minus t by tau is equal to general expression. I mean I1 of t, I of t. But at t equal to tau, its value should be I1. And this equation 192, we have to manipulate. So how this is solved? E by R plus E1 minus E by R. This is tau cancel. Na? e power minus 1 equal to I2. Then I1, solve for I1. This equation, solve for I1 is equal to so and so. Then I1 is equal to, this you simplify further, solve for I1, just go through mathematical steps. I1, I1. So wherever I2 is there, here what is this expression? I2 equal to e power minus 1 is equal to I1. Okay. So this I2 is replaced with when it is coming this side, I1 e power 1. Then solve. Simplify equation. Okay. So these two steps are important, critical problem. This problem also solved. Simple only. So just let me go through a little bit fast. So switch is moved to, which is moving from 1 to 2 at t equal to 0. Here 5 u of minus, not u of t. So there is a capacitor, inductor, and so on. Find IL 0 plus and VC 0 plus. So as usual at t equal to 0 minus, which is connected to number 1. 0 minus. Capacitor and resistor. Here actually open circuit. Open. And the inductor short circuit. And 0 minus, this value is 1, so 5. 1. So what is this voltage here? It's 3 into this 3 volts divided between 50k and 100k. Therefore 3 into 100k by 100 plus 50, 150, simplify 2 volts. Then IL 0 minus is going like this. 5 by 500. 5 by 500 is 10 milliamps. VC0 plus same as VC0 minus 2 volts. IL0 plus same as IL0 minus 10 milliamps. Now again draw the equivalent circuit at 0 plus. Now 0 plus carefully, switch is connected to 2. This capacitor replaced with a voltage source. Voltage source of 2 volts. And this is connected this side. Inductor replaced with a current source of 2 milliamps. And 0 plus, what is this value? 0. So this is existing only left side, not right side. This is 0. This is 0 means short circuit. Shorted. So this is the equivalent circuit at 0 plus. Now, what is the voltage applied here? 2. If this is 2, what is the voltage here also? 2. 2 by 500. 2 by 500 is 4 milliamps. Current flowing here is 4 milliamps. Current here already given 2 milliamps. Therefore, IC0 plus must be 10 plus 4, 40. Okay. Next, write the mesh equation here. Minus 2 plus 1 by c integral I dt. This is the discharging current. This is the initial voltage already there. Minus infinite to 0 minus is initial value that is already taken. 0 to t is the further. Plus voltage here is LDIL by dt equal to 0. Just written the mesh equation. Now at t equal to 0 plus, this is anyway 0. This is 0. Solve for DIL by dt 0 plus, you got 100 amps per second. Next, we want to VC of t. VC of t. This expression. What is that expression? Voltage in the capacitor is initial voltage to and this is discharging. So minus 1 by c integral I dt. Differentiate this dvc by dt equal to derivative of t is 0 minus 1 by c I of t. And Vc 0 plus is I 0 plus substitute. Simplify, you will get minus 400 volts per second. Okay. The fundamentals here is, for example, there is a capacitor. This is the current flowing in this direction. Now I want expression for Vc. And initial voltage Vc 0 minus with this polarity given is V prime. So how to write equation? Started positive, go to negative. Na? So V prime 1 by c integral 0 to t 0 or 0 plus I of t dt. In this case, it can be reverse. Vc 0 minus maybe minus V prime. Current going like this. Vc of t. So to write Vc of t minus V prime plus 1 by c integral 0 plus 2 t I of t. Just possible situations. Current can be reversed. Current may be going this side, and initial voltage with that polarity may be plus V prime. Now I want expression in this form. How to write here V of t expression? Started positive, go to negative. Positive to negative is plus. So V prime. But our direction, current direction opposite, na? Now minus 1 by c integral 0 plus 2 t I of t. If this is plus, this is minus, capacitor is discharging. Here capacitor is charging. Here discharge. So like that we can write depending on the general equation is minus infinite to t. When I have taken 0 plus 2t, this is initial. So minus infinite to 0 minus taken care already. 0 plus 2. So like that inductor also we can write. So I stop at this moment.